All right, 6, 4, finishing up. 6, 4, mixing it with 6, 6. They go together. So we're going to talk about the phase shift, the period, and the amplitude. I did edit this just a tiny bit. I thought it made more sense, sounded better this way. So here we go. The coefficient of x is horizontally compressing or stretching the graphs, and it's determining the function's period. So here we have, and again, pause the video anytime you want. Here we have an example. And I went ahead before the video and put this down so you didn't have to watch me put the parent function together. But I'm going to multiply x values in the parent table by 3 over 2. So you're using the reciprocal, okay? So multiply by 3 over 2, multiply by 3 over 2. And what do I get? I get 0, 3 pi over 4, 3 pi over 2, 9 pi over 4, and 3 pi. So now I'm going to label my x-axis with this pattern. So we've got 0, we've got 3 pi over 4, and 3 pi over 2, he's right here. 9 pi over 4, he's right here. And then 3 pi. So here's where I get a little nervous. I want to make sure that these intervals that I'm marking are equidistant. If they're not equidistant, then I'm going to have a little funkified looking graph. But if it doesn't bother you that yours is kind of funky, then don't worry about it. It bothers me, and I see students get a little confused themselves when theirs aren't equidistant. So I was trying to make a point about that today, and it didn't come across, I don't think, as a point I wanted to make. So here we have, let's graph them in black, a stretched sine curve. It's taking a little bit longer to finish its cycle. So 1 period of cosine is a half a W. And then I can extend it on the other side by using the same pattern that's on the right side. So he's still a even function. It's still reflecting in the origin. I'm sorry, not the origin, the y-axis. Even is in the y, because he didn't shift over. All right, so negative 3 pi over 4, negative 3 pi over 2 is going to be used. I'm just highlighting the marks. 9 pi over 4, negative, and then 3 pi, negative 3 pi. All right, so this is just me going a little further than what I did in the notes. So you can really see that it is stretching out. I pulled the W apart, or not really apart, I just stretched it. Just stretched it like some taffy. Saltwater taffy. All right, there you go. So he is it. This big one right here. He is a stretched, horizontally stretched graph of the cosine curve. Okay. All right. Period. That's a period. So the period is the length it takes for a graph to complete its cycle before repeating its shape. So this guy had a period of 3 pi. It took 3 pi units before it started to repeat. A half a W is 1 cycle. And the way you can figure out a function's period without looking at the graph is you use this formula right there. And you can see it back in that table. So if I look back at the table and I look to see what happened to 2 pi after I applied the coefficient of x to it, And when you apply the coefficient of x, you use the reciprocal. So the coefficient of x was 2/3, so I multiplied 2 pi by its reciprocal. So, whoops, that one still, so 2 pi divided by b, so divided by 2/3. So that's just 2 pi divided by 2/3, which becomes times 3/2. Okay. So you can find it down here. You can find that period. All right, then the next one is amplitude. So remember that the coefficient of a function vertically compresses it. Vertically, so coefficient of the function is going to vertically do it. So let me highlight it here. Coefficient of the function is going to vertically compress it or stretch it. Coefficient of x was what we just saw. That's going to horizontally stretch it or compress it. So this guy's determining the amplitude. So here's sine's parent table. So let me graph him in here. I made the table. I should have included the graph. Anyway, this doesn't take too long. There it is. So 2 backwards s's on their sides is a sine wave, a sine curve. So now to apply this transformation, I'm going to multiply all the y's by 5. So you go way up here, you stay there, you go down here, right? This is -5, this is 5. And then this guy comes here, and here. And so the amplitude is always measured from that horizontal axis, and we call that horizontal axis the midline. So we're only measuring from here to here. You could also say I'm measuring from here to here, but you don't measure this whole thing. Okay? So this guy's amplitude would be 5. The parent function's amplitude is 1. All right. So here's an example where they're asking you not to use a graph to figure this out. So I would say my amplitude, oh my gosh, is the coefficient of the function. You take the absolute value of it. So it's 4/3 tall, 1 1/3 tall. And then the period, I use the coefficient of x and I divide it by, so this is sine. So sine's period, the parent function's period is 2 pi. So I'm going to say 2 pi divided by 2/3. Right? So that's 2 pi. You don't need to do the baby steps, but why not one more time? So it's just 3 pi. All right, this was the same coefficient. I should have changed this one. He was the same one as I had above. But there you go. All right. So that was for these 3. This was back in 6-4. So now we're going to continue with this in 6-6. All right. So why are we calling these sinusoidal functions? So we wrote down our parent tables again, and I noted that they're the same. Actually, where did I do this at? 1, yeah, 1, 0, -1. Okay, and I showed you that if I moved one of them, I would get the other one. But how much would I have to move it? And they're a half a pi from being the same. They're a half a pi, so if I move the red one to the right, it would sit on the blue. If I move the blue one to the left a half a pi, it would sit on the red. So here it is real quick in Desmos. See it one more time. So y equals sine x, y equals cosine So there they are. Now let's say I want to move my blue one so that it's on top of the red one. I don't know why all those points are there. Let's say, oh, because I guess I'm highlighted on them. Let's say I want to move this blue one, the cosine curve, so it moves to the red one. I have to shift it to the right. So it's always x minus h. So the h value I want to add, I want to make it go to the right. So I got to put in a positive pi over 2. So it's going to be x minus positive pi over 2. And there he is, sitting on top. And then I could go the other way. I could make the sine curve, the red one, sit on top of the blue one, but I got to get him to go to the left. The red one has to move to the left, so it's going to be x minus a negative pi over 2. And there he is on top. So that x minus a negative pi over 2 is going to be x plus, and that's what we wrote down here. All right, so I said, notice that they're the same. So this is saying what I was just blabbing. If you want to write it down. And so we just discovered this by looking at it in Desmos, but understanding it could happen. And here's the other one. So cosine can be written in terms of sine, and sine can be written in terms of cosine. So write that down, pause it. Now here's the sinusoidal functions. So I'm not a big fan of omega and phi, capital A, capital B, but that's how they have it in the book. And then it just depends on who's writing the book. Not everybody agrees, right, in the math world on certain letters. So I'm going to stick with the ones we're familiar with. I'm going to stick with A is the coefficient of the function. H is horizontally moving it. K is vertically moving it, it being the parent function. And then we have this 1 over B. I'm leaving it not like that. I'm just going to leave it as this is the coefficient of x. And whatever it is, it has to be factored out. And I wrote that right here. It's very important you factor it out. And whatever it is, you multiply the x values by its reciprocal. Okay, so make sure you get it factored out, and that's what we're going to do in our first example. And this allows us to see the amplitude. I'm sorry, not the amplitude. Well, it does allow us to easily see the amplitude, but I was trying to say phase shift because I haven't mentioned phase shift yet. Okay. All right. You won't know the phase shift if you don't have that guy factored out. So here is the 3 ideas for the sinusoidal functions written instead of written as the transformations. So I'm not saying multiply. Transformations, I always say this guy, you're going to multiply the y values. What is it going to do? It's going to vertically stretch or compress. Well, since it's a curve, it's this periodic function, he's got this amplitude, sine and cosine. The other guys don't have an amplitude, by the way. He has a period. He has a phase shift. So our polynomials and all our other algebraic functions, they have all these transformations as well. But because this is this sinusoidal function, this is a trigonometric function that's periodic, not just sinusoidal, I should just say it's periodic. I can mention these ideas. I can't say these so much with the cubic function or the square root function. I really only say it for periodic functions. Okay, so here's an example that I didn't finish up with you. I don't think I finished it up. I think I just started it with you. So what are we on, the 14-minute mark? Okay, so I'm going to factor out the coefficient of x. And I have to say, so I have a little thought over here. I think to myself, I say, all right, if I'm going to distribute this guy back through, he's got to multiply. This guy back here has got to end up being pi over 2. So what am I going to multiply 2 by to get pi over 2 back? And I really don't think it needs to be written down. I think you can figure it out. That's why this is just a thought bubble. I don't need to see that you thought about it, but definitely write it down if you're struggling thinking about it, right? I'm a very visual learner, so I probably wrote that down a lot. So what is it, pi over 4? Okay. So it's asking you to find the amplitude, period, and phase shift. So you can answer that question right now, but you are also graphing it. So the amplitude is just 4. It's positive 4. The period is 2 pi divided by 2. So it's just pi. And then the phase shift is pi over 4 to the left. Right? Pi over 4 to the left. He went x minus negative pi over 4. Actually, let me just use right? All right. That's my phase shift. That is it. So that's why it's very important you have the period value, the value that's determining the period factored out. It can't be in there with it. All right. And it even says it in like this. It says get these guys all isolated. And even in this ugly form, actually I didn't write the ugly form. Have the omega factored out. So graphing it, give yourself a parent function and make sure you get the right guy in there. This is cosine. So 0 to 2 pi, all the quadrantals. All right, so I've got lots to do here. I'm going to multiply the y's by negative 4. I'm going to multiply the x's by a half. So this is 0, this is pi over 4, pi over 2, 3 pi over 4, pi. And so again, just to say it again, the period can be found right here. That's where you find it. And then the last thing, I gotta add the phase shift to my x values. I'm gonna move my table over because I think I might run out of room. So let's see, adding negative pi over 4. And I'm even gonna do this, give myself some more room. I'm going to subtract pi over 4 from all of these. And I would really love it if you had it all together, so I wasn't looking for your work. Like if you could do your transformations in the table. You can organize it my way, you can organize it any way you want. This is just what I've come up with. I go the right to left. So 0 minus pi over 4 is negative pi over 4. Pi over 4 minus pi over 4 is 0. I'm going to give myself some lines. And then pi over 2 minus pi over 4, that's positive pi over 4. 3 pi over 4, take away pi over 4 is pi over 2. And this is 3 pi over 4. So these are just simple fractions. They might not look like simple fractions because the pi is in there. You can ignore the pi and throw it back in the numerator when you're done dealing with the simple fraction, right? The simple fraction being this is just 1/4, take away 1/4. This is a half, take away a fourth. A half, take away a fourth is a fourth. Okay, put the pi back in. 3/4 take away 1/4. Plus 3/4 take away a fourth. That's a half. Put the pi back in. Okay. All right. I'm ready to graph. So these are my ordered pairs. If you need to see them, you can write them off to the side so you clearly know your ordered pairs. All right. And I'm going to show 2 periods. So I know this is 1 period because I gave myself a parent function for 1 whole period. And now I'm going to draw a set of axes. You know what I'm going to do? I'm going to copy this because I don't want to keep bouncing back and forth. All right. Actually, which way? I think I'm good. It went to the left. Actually, I think I'm going to put this. Yeah, it's fine right here. Okay, that's good. That's good. So I'm going to go 1, 2, 3, 4. 1, 2, 3, 4. So make sure you clearly label your axes. And then I'm going to count by pi over 4 increments, right? Pi over 4, add pi over 4, get 0, add pi over 4, get pi over 4, add pi over 4, get pi over 2, add pi over 4 to pi over 2, you get 3 pi over 4. And here's where I did at one point, I think it was today, I wrote these in degrees. So if it's easier for you to count in degrees, then by all means, jot them down off to the side. So here's what I'm trying to say. I need to make sure I label my x-axis in the same increments. So how are your x values changing in this transformation? They're changing every 45 degrees. The key points move. Let's say the key points are popping up every 45 degrees, but I want to label my x-axis in radians. So negative pi over 4, positive pi over 4, zeros there, pi over 2, 3 pi over 4. So this is 1 period. So plot your points. And there you go. And then we'll continue with this pattern, counting by pi over 4s. So adding another, or subtracting. So if I'm going to go to the left, I'm going to add negative pi over 4. So this would be negative pi over 2. This would be negative 3 pi over 2. No, it wouldn't. It'd be negative 3 pi over 4. And then negative, what am I counting by pi over 4? So negative pi. I guess I need to go one more. I need a complete W, right? So negative 5 pi over 4. Okay. So this did have a reflection occurring. So our W is upside down. And this wave goes on and on and on forever. All right. So that's 2 periods. I think it says 2 periods. Yeah, I think I wrote that verbatim. 2 periods. Label the key points. All right. So they are really looking for you to label. So if you do use the back of the book to check your answers, they're going to have them labeled. I'm okay if you don't, because I need to see what you did to the parent table. So as long as you're doing your transformations, you will automatically have your key points listed. So you don't have to cram them in the graph. It'll just get too messy. Clearly label your x-axis and your y-axis. Make sure you apply your transformation. So I should see this, okay? and then you'll be